Let's get started with Part 3 of the Exam 1 review. In this problem, we're told that temperature rises according to the equation temperature equals 15 plus 0.1014 D. Now, temperature is expressed as T of H. That means temperature is a function of height, the height of the Earth. So the T of H is just temperature. You don't have to multiply or anything like that. And the D is the depth. So really, it's re-expressing height in terms of depth. Okay, so we're going to use that equation and find what the temperature is when the depth is 985 meters. So all we're going to do is plug 985 in for D, and we're going to use T of H equals 15 plus 0.014 times 985. Well, you know, I told you when you're dealing with functions, like f of x, for instance, instead of f of x, you can write y. So let's do that. For temperature, instead of T of H, let's write y equals 15 plus 0.014 times 985. So that was easy. Our problem becomes the challenge of multiplying 985 by 0.014. Now when you multiply by something like this, it's the same as multiplying by 985 times 14, which would be 5 times 4 is 20, 8 times 4 is 32, plus 2 is 34, 9 times 4 is 36, plus 3 is 39, and then we deal with the 1, and we get 0, 9, 9 is 17, 9 and 4 is 13. Okay, but if you remember, we weren't multiplying by 14, we were multiplying by 0.014. So after you multiply by 14, you get some humongous number down there. Then you go back over here and you count from here 1, 2, 3 points. The decimal was moved from here to 1, 2, 3 places. So it needs to be moved from here 1, 2, 3 places. So we write our new decimal right here. So our answer is 13.79. So y, which is the temperature, is 13.79 degrees in centigrade. Degrees centigrade. Now, it tells us, and this is very important, we always need to pay attention to the little directions. Round to the nearest hundredth. Are we at the nearest hundredth? Well, this is the tenth, and this is the hundredth. So yes, we are rounded correctly, so that is our answer. So our temperature, is 13.79 degrees Celsius. Okay, now you can move on to Part 3 of the review. What is the equation of the line with a slope of 3 and a y-intercept that crosses the y-axis at -5? That is very easy. You just use your y-intercept form, y equals mx plus b, and leave y and x alone. There's still y. Plug in 3 for m. And then for b, we're going to put -5. And that's it. Okay, let's graph a line that goes through the point -3, -4, and has a slope of 5, 3. So we find the point -3, -4. X is -1, 2, 3. Y is -1, 2, 3, 4. So we plot a point there. And then we use our slope and we count up a rise of 1 from this point. We go to the point -3, -4 and count 1, 2, 3, 4, 5 up, and 1, 2, 3 over. So our next point is going to be right there. So we can easily, hopefully, draw the line that passes, pretty good, passes between those 2 points, and voila, we're done with that problem. What if we were to graph an equation with a 0 slope that passes through the point 2, -3? Well, if it has a 0 slope, it's like a flat roof. It's horizontal. So we know we're going to go to graph a horizontal line, and we know that a horizontal line has a y value, but it doesn't have an x value, because we've learned that. So we have y equals something. Now this horizontal line is going to pass through the point 2, x equals 2, y equals -3. So it's going to pass through that point. We can go ahead and draw that line. We don't have to wait. So there is, whoops. So that's better. So there's our line that goes through the y-axis at -3, and that line is going to be called y equals -3. So now move on to part 4 of the Exam 1 review. Now we have another problem where we're going to find not just the slope, but the equation of a line that passes through 2 given points. So to find the slope, we're going to use the slope formula, and then we're going to have a point and a slope, so we'll use the point-slope formula to find the equation of the line. So the slope is y2 minus y1 over x2 minus x1. Doesn't matter which is y2 or y1, we just have to be consistent. So we'll start with -1 minus -3 over -2 minus -5. And then remember, a minus and negative is the same thing as a plus, a positive. So our numerator is going to be -1 plus 3. When you have a negative and a positive number, you find the difference of their absolute values, and the difference of 1 and 3 is 2. And then you give it the sign of the larger number. In this case, 3 is positive, so we have 2 in the numerator. And in the denominator, we do the same thing, and we get +3. So our slope is 2/3. Now we can use our point-slope formula, which is y minus y1 equals m times x minus x1, where y and x don't change. They stay y and x. What changes is we substitute in for y1 and x1 and m. So what we want to do is decide which of these points up here we're going to use, and it doesn't really matter. I'll use -2 and -1 because they're littler numbers and we like little. So let's do y minus -1 equals m times x minus -2. And again, we change minus and negative to plus a positive. You'll be able to do that in your sleep pretty soon. So we get y plus 1 equals 2/3 x plus 2.
Speaking of sleep, this lesson is putting me right there.
And that was one of my obnoxious children making a comment, but of course it isn't putting you to sleep, is it? Okay, so we go on. Y plus 1 equals 2/3 x plus 2/3 times 2, and when we multiply by a whole number, we make it a fraction of 2/1. So we have y plus 1 equals 2/3 x plus 2 times 2 is 4 over 3 times 1 is 3. And now we need to get rid of this 1 so that we can have a slope-intercept form. So we have y equals 2/3 x plus 4/3 minus 1. But we're going to change that 1 to 1 over 1 because we're now combining fractions, and what we're looking for is to get a common denominator between 4/3 and 1 over 1. So to do that, we're going to multiply our 1 over 1 by 1 in the form of 3 over 3. That will give us a denominator of 3. So here we have, I'm just going to go ahead and work this, 4/3 minus 3/3 equals 1/3. So we can plug that 1/3 into there. So we get y equals 2/3 x plus 1/3. And that is our equation of our line. Write the equation for a line that passes through the point 3, -7, and is parallel with the line 5x equals 6y plus 8. So what we're going to do is we're going to put the equation in slope-intercept form, which is y equals mx plus b, and that will tell us the slope of the first line, the line that we're given. A parallel line has the same slope, so we will know what the slope is, and then we are going to plug in the point 3, -7 into y equals mx plus b to solve for b, and then we'll have what we need to know for the equation of the second line, the parallel line. So let's get started by converting 5x equals 6y plus 8 into slope-intercept form. We want to get the 6y term on the left and the 5x term on the right, and instead of messing with negative numbers, let's just rewrite the equation by switching sides. And now we want the 6y to be by itself, so we subtract 8 from both sides, and we get 6y equals 5x minus 8, and then we divide both sides by 6 so that we can get y by itself, and we have y equals 6x minus 8/6, which reduces to 4/3. And that's the equation of the first line. That's not what we're looking for, though. From that equation, we can see that our slope is going to be 5/6. So our new equation is going to look like y equals mx plus b, and we know our slope, which is m, is 5/6. So we can rewrite that equation like this. And we also know that this point that we're given is on our new line, which is the parallel line. So we can find b one of two ways. First, we can take this point and plug in the x and y values and solve for b, or we can use the point slope formula. So I'm going to take these points and solve for b, and that is I'm going to substitute -7 instead of y, and 3 instead of x. I'm going to put it as a fraction because we're multiplying it by a fraction. So let's look at what I've just done. I've taken my 3 and I put it in for my x. I've taken my -7 and plugged it in for y. Now I'm going to simplify and solve for b, and let's look at the fractions. 5/6 times 3 over 1. The 3 goes into 3 one time, and the 3 goes into 6 two times. So all of this here becomes 5. 5 times 1 is 5 over 2. So that's going to become 5/2. So now I'm going to come over here and rewrite what we have. -7 equals 5 halves plus b. So now all I have to do is subtract 5 halves from both sides, and I'll get b by itself on one side. So I have negative 7, and I'm going to put it over 1 since we're dealing with fractions, minus 5 halves equals b. Now, to subtract fractions or add fractions, you need a common denominator. The common denominator is going to be 2. So we have to multiply the denominator of the first fraction by 2, and that means we have to also multiply the numerator by 2. So that gives us, multiplying the numerators, negative 14 halves minus 5 halves equals b. So negative 19 halves equals b. So we've been looking for b, and there it is. Now we can plug b into this equation here. This is our parallel line, and we've been searching for b. And when we plug it in, that will be our solution. So our final solution is y equals 5, 6 x minus 19 halves. This problem is similar to the previous problem, only we are to find a perpendicular line. So that means we have to take the given line and figure out what the slope is. And for a perpendicular line, we need the negative reciprocal of that slope. That is what we'll use in our new line. So let's go ahead and do that. We want the 5y to be on the left, so we're going to subtract 2x from both sides and then divide by negative 5. And we're left with y equals, and negative over a negative is a positive, and a positive over a negative is a negative. So there's the first line in slope-intercept form. Here's our slope, 2/5. The negative reciprocal is going to be negative 5 halves. So the new slope that we're looking for, I'm going to put it in red, m should equal negative 5 halves for our perpendicular line. So now let's write our new line. We're going to write y equals mx plus b. And this line, this new line, is perpendicular to the line we started with because it has the negative reciprocal of a slope. So now we have to find what b is, and this time I'm going to use the point slope formula to demonstrate that. The point slope formula says that y minus y1 equals m times x minus x1, so you need to memorize that. x1 and y1, here's x1 and y1, so we plug those things in. y minus and y1 would be negative 7 equals, and then m we know is negative 5 halves, and then we have x minus, and then x1 is going to be 3. So I brought my negative 7, plugged it in for my y1 here, and you have to be careful of the negative signs. You keep the minus, and then you plug in negative 7, and then I plugged in 3 for my x1. Continuing, y minus negative 7 minus a negative is the same thing as plus of positive, so we have y plus 7 equals, and now we're going to distribute the 5 halves, negative 5 halves times x and negative 5 halves times negative 3. So we get negative 5 halves x, and we'll say minus, bring this minus sign down to be careful of our negatives, and then we are going to say negative 5 halves And we've already brought the minus down, so we can just write 3, which we should write as 3 over 1, because we're going to be multiplying by a fraction. So that gives us y plus 7 equals negative 5 halves x plus, because minus a negative is plus a positive, so we have plus, and then the numerators make 15 and the denominators make 2. But we're not done because we don't have y equals mx plus b. First we have to subtract 7 from both sides, and so we get y equals negative 5 halves x plus 15 halves minus, and then since we're going to have to combine fractions, we write it as 7 over 1, and to get the denominator of 2, we multiply by 2 over 2. So this becomes 14 by multiplying the numerator and halves, 14 halves. That gives us y equals negative 5 halves x plus 15 halves minus 14 halves. And when we combine the 15 halves and the 14 halves, we just add the numerators and keep the denominator the same, so 15 minus 14 is 1.